Thank you all for joining. Today, I'm going to talk about AKS, Azure Kubernetes Services, and I'm going to focus all around security around AKS. But before we can really dig into the security components, it's important that we realize a bit what you get if you just deploy Azure Kubernetes Services. So let's see what you get if you just start with it. This is a slide actually provided by Microsoft. It gives you the reference architecture of AKS, and it contains a typical deployment, where in the left bottom you will have the management capabilities of AKS. You have your Azure pipelines doing Helm upgrades or creating containers that are being pulled by Azure Kubernetes Services. You have the DevOps guys maintaining your cluster, monitoring your cluster. In the center, you have your workload, and in the left top, your customer application. So this is actually the gateway to the outside world. The backend services contain your backend services in Azure that are doing the persistence. So you see a lot of components, and it's not just one single thing that you deploy to Azure. So let's take a look what you really get if you just do a next finish deployment of AKS. You'll actually get two resource groups. One is the resource group where you have deployed your Kubernetes cluster. So this actually contains Kubernetes. And you get a second resource group for free. And that contains all the other stuff that you need to run Kubernetes. How does it look like in real life? Over here, I have a Microsoft Azure environment with a resource group dedicated to this build talk. This contains Azure Kubernetes Services. This is basically the entry point. That's the left column that I've just shown in my slide. The right column is a second resource group that got created while creating your cluster. And it's always named MC underscore and then the resource group mentioned over here, and then the name of your cluster. Inside this resource group, you will get all kinds of resources required to run your workload. For example, a virtual machine skill set. This one is really tiny because I've just deployed this for this demo, but you can imagine if you do enterprise workloads that you'll get a lot of resources over here. You probably need disks to persist stuff. You get additional load balancers, more virtual machine skill sets, etc. Now, by far, the most important thing if you want to secure this entire environment is that you want to protect your API server. The API server is mentioned in the left bottom of my architecture diagram that I've shown in the start. And it contains all the components who are doing remote management of your cluster. And then let's underline remote management. If you're able to remotely control your cluster, you can also introduce remote vulnerabilities. They're even out in the open on the internet if you don't protect it. You really have to protect them because all you need to access your cluster as a DevOps guy or as a pipeline is a kubectl.config file. And the kubectl.config file is just present on your machine. So let's open up a Explorer window here. Let's go through my user profile directory. This user profile directory contains my desktop, my contacts, my documents, etc. But there is also a .kube folder over here. And this .kube folder contains a config file. If I would open a config file, I would see details like this stuff in the right bottom. This config file contains a certificate data, it contains a key, and it contains a refresh token, which is all you need to access your API server of Kubernetes Service. So if I send this file to Sjoukje, I'm lost and Sjoukje can access my cluster. I really need to have control of who can do this. There are a couple of options for that. The easiest option is to set an authorized IP range list of IP address ranges who can control that cluster. In this case, it is my own private IP address, so it's a /32 range. In case it is your office, it might be one of your outgoing IP addresses. You can even add more ranges if you have multiple offices or multiple departments who have different outgoing IP addresses. But in the end, it's still not really a controlled environment, because right now I'm doing it from my home, but it still means that my daughter can access the same cluster. And if you're doing it from the office, then your entire office, all your departments who share that outgoing IP address are using the same outgoing IP address, so they are all allowed to access your cluster. So it's probably better to create an internal cluster. That's the second option. If you enable the private cluster, then not your entire cluster is internal. Your customers still have public endpoints, so you can still distribute your applications on the internet, but the remote management part is shifted to internal. And that means remote management can be dealt by your network administrator. For example, the network administrator can create an express route to your network, or it can introduce a demilitarized zone with stepping stone. He can help you, and then you can really fine grain your control to the API server. You can also consider to disable the public domain of your Kubernetes cluster, and that means you can only access it by an internal IP address instead of using the publicly well-known address of your cluster. You can just guess it. This is all quite nice, practically making it impossible to remotely manage your cluster. But you do need to manage your cluster. You need to deploy workload on it. You need to do application upgrades. You introduce new stuff, new namespaces, new applications. So whenever you need to do a deployment, then you're probably doing it by pipelines, which means that you need to have a build agent that is able to communicate with your API server. There are a couple of options for that. For example, you can deploy an agent inside the VNET. It's quite easy, but the agent itself also comes in a containerized version. So you can download a container image for the VSTS agents. It's been published by Microsoft. And if you deploy that inside your AKS, you're in the VNET, and you can deploy workload from that build agent to your own AKS server. You can use that for deployment, but not for building purposes. You don't want to build container images inside a cluster. And that basically means that you need to have a gateway from your container towards the container engine of your node. That is actually reducing your security. You can also consider to introduce GitOps, which is putting the world a bit upside down, because when an agent is actually pushing your workload towards the cluster, GitOps is doing it the other way around. GitOps is remotely monitoring Git resources, and as soon as sources in that Git repository will change, it will apply those changes in your cluster. So it means instead of pushing things to your cluster, you're pulling things. And that switch from push to pull greatly reduces your firewall complexity. GitOps is, well, it's quite doable. It takes a couple of hours to set up in the first place, but also note that Microsoft is working on this to make it even more intuitive. Note that the GitOps preview extension has been added to the blade in the left of AKS recently. So as soon as this goes out of preview, it's probably just a couple of clicks to get GitOps up and running and get your resources linked to a remote repository. Let's focus on the network. Because in the right of the reference architecture that I've shown in the start, you saw there were external sources over there. And these are the icons for Azure SQL or Azure Cosmos DB. They're marked external over here, but do they have to be external? That's basically the question. They don't have to be. Azure has quite a cool functionality for this, using service endpoints and private links. And using service endpoints and private links, you make your external sources internal. Let's again go to Azure. Inside the resource group over here, I've deployed a Azure SQL instance. This. The same counts for Azure SQL. I need to control who is able to access this server. in the security here in the left, you can see that I've denied public network access. And that implicitly also disallows all the other Azure services to connect to this resource. So basically no one can contact this server, except the virtual network that I've added over here. And this is also the same virtual network that runs AKS. You see that it has an address range of 172.16. And by adding a private endpoint connection, you're going to add a link between Azure SQL and the VNET. This private endpoint has a DNS configuration. You see in the DNS configuration, it will add an extra network interface on the VNet. It gets an internal IP address, and by adding a private DNS server, you can automatically link the FQDN, so the fully qualified domain name of Azure SQL. You link that domain name to the internal IP address. How does that look from inside? Let's do a few commands inside the AKS cluster. Inside the AKS cluster, I've already deployed a pod. The pod is the tiniest possible thing to run a container image. Which image am I running? I'm running a BusyBox image. And BusyBox is a small Linux container containing a few popular command line utilities of Linux. The container itself isn't doing anything, it just sleeps, but this allows me to execute commands from inside Linux, inside the AKS cluster. Now, what is the command that I want to execute right now? So I'm going to execute in the default namespace on the BusyBox a ping command. And I'm going to ping the Azure SQL instance shown here. Azure SQL isn't actually responding to ping, but you can still see how this Azure SQL instance got resolved. And you see it uses the internal address of the VNet. So using this, let's break it. So using this, you have basically pulled your external sources inside the VNet of AKS. And this is not an Azure SQL only story. You can do this for the most popular Azure resources like Azure Storage or Cosmos DB or KLYVAULT. Even Azure Container Registry is having this feature in preview functionality. Let's continue, because as soon as I'm able to access the Azure SQL instance, I need to be able to connect to it. And that connection string usually contains a secret. Now, how do we get those secrets inside Azure AKS? A pretty straightforward way is to inject those secrets straight from the pipeline, because your pipeline is able to access your key vault. There's a regular task available in all the Azure DevOps pipelines. It's called Azure Key Vault Add To, and this retrieves all your secret and certificate data as a variable inside your pipeline. As a subsequent step, you can use those variables and apply them in a replace token task. Let's see how that works. Again, we're going to the cluster. I have a deployment over here. A deployment is running one of my containers. It's this container I've specifically created for this talk. And this container needs a connection string. This connection string has to be injected because pure configuration needs to be injected into containers. And the popular way to inject data in containers is using environment variables. If you have injected it, then you can initialize an SQL connection using the value in the environment variables. Now, how do you do that? See over here, inside this container, I have an environment part. And here I say I want an environment variable with the name connection string. And instead of putting a hard-coded value here, because that would basically persist your secret inside your Git repository, which you don't want, I'm going to reference a value from a secret key reference. And the secret key reference is also named connection string. This is not a key vault secret. This is a regular Kubernetes secret. So the connection string over here is referring to the connection string over here. And we have to fill this secret with the data of the connection string. And over here, you only see a macro syntax. So this is not the real secret. And that is the part that you can inject using the pipeline. If you have the pipeline over here, you can run the Azure Key Vault task. It will download all the secrets, also the certificates. You can filter them. I didn't do that, but you can do that. And then using the replace token task, you can replace that contact. So I have a custom token pattern with the macro start tag and the macro end tag. And immediately afterwards, the deployment YAML file is ready to be deployed. And by using these 3 steps, you can inject secrets just before deployment. The same option is there for certificates, and the good thing for certificates is that the output of the Azure Key Vault task and the input for your secret inside Kubernetes is both base64 encoded text. So base64 encoded text comes out the task, and that's the same content that you can inject straight into your certificate and key data. This is one way. You already saw that the parsing of the YAML file was a bit awkward. There's a more clean solution recently introduced. And in fact, that option is also the only way if you're doing it the GitOps way. Because if you're doing it the GitOps way, then you're remotely monitoring that YAML file. And in that YAML file, you don't want to persist and commit and push secrets. You're lucky, the Azure Key Vault provider for the secrets is a CSI driver that has been promoted recently to general availability. So it's ready for use in your production environment. And this uses Azure Identities to read secrets and expose them in volumes. You have to enable an add-on while activating AKS. You can also enable the add-on later, by the way. And it works slightly different, but quite interesting. Let's take a look at that. Again, we're going to deploy a busybox container. Again, sleeping, not doing anything special, but in the bottom you see an extra addition. I have mounted the volume to mounted drive secret store, and this mounted secret store is a volume here. The name of this volume mount is referred one-on-one in this volume, and this is a CSI with a driver of secret store. It's read only. And it's referring, there's a line missing over here, I guess. Yeah. Well, that was a surprise. It's referring to a secret provider class, which is called Azure Key Vault name, user Microsoft identity, Microsoft Service identity. Well, there it is. This is the secret provider class referred over here. This secret provider class actually refers to the Azure resources. So I'm going to Azure. I'm not using polo identity, but a managed identity. And the managed identity that I want to use is this GUID. Well, where does this GUID come from? We got that for free when we enabled the Azure Key Vault add-on in AKS. When we enabled the Azure Key Vault add-on, we got an extra identity. Inside the node or resource group, there's suddenly here a managed identity called Azure Key Vault Secret Provider. This is the identity that has read access to my Key Vault. This Key Vault. And I'm going to expose only one secret, and the secret is called CSI sample. Let's go to that Key Vault. Inside the Key Vault, I have the secrets. We had the connection string already. And now we are going to look towards the CSI sample, and the value of this secret is, well, secret, of course. But how do we get this in? I've already deployed this, so I can execute a command over here. This is the deployment. And then I'm going to do a list on the mounted volume and see what's inside this pod. And you see there's only one file over here, and the file is called CSI sample. So it's actually a file. Now, what's present in that file, we can show you that using the cat command. And that's going to expose something really secret. So using this, you can access your secrets from a separate container. You can refer to a CSI driver, and the CSI driver will fetch the key vault stuff for you. And this also means that you don't have to persist your secrets in your Git repository. So very cool. You still have to be beware. Secrets are not secret anymore if you have access to the API server. You saw the resources that I've just deployed. If you do kubectl get secrets, then you'll be able to see the internals of the secrets as well, and they are just base64 encoded. They're also not secret if you have access inside the running container, because you just saw a secret is just a plain text file, and it contains the secret over there. And the environment variable is also not encoded. So you have to make sure that nobody has access inside your container. The software that you run over there needs to be secure. The first example, where I replaced it just before deployment, will also make you responsible for destruction of the replaced file. You don't want to persist that, because then you're persisting content, including your secrets. Let's go a little bit further into those Azure identities, because AKS is even more integrated with Azure identities. And especially in the management part, you will notice that. If you create your AKS cluster, you have the possibility to enable managed identity. And that managed identity is used to manage your cluster resources. So again, that node or resource group comes into the picture. How does it work? At the time of AKS creation, I had a managed identity which I linked to this AKS cluster. It's just an additional command line. Now, what happened under the hood? The node or resource group that got created next towards AKS has a role assignment to the same user managed identity. So this way you can control who has access to your node or resources, and AKS will use this identity only. The same trick is there for hooking up your AKS environment to a container registry. It will use a slightly different identity, but it's still managed. And it will just grant the ACR pool role to the managed identity. You can also link the roles inside your cluster to the Azure roles that you have. So if you enable AAD and enable Azure RBAC, then you can link the admin group object IDs to your AAD group IDs. You can even disable local accounts, and this means that you have entirely promoted your management user infrastructure to Azure, which is cool for management. But on the other hand, you also want to run your workload using Azure identities. And over here, the story is slightly different. I'm not that optimistic on that as per today. AAD pod identity has been there already around a year or so. It's actually still in preview phase, and that's where the caveat is. It's a long time in preview, and I'm convinced it won't make it to generally available. And V2, already the replacement of V1, won't make it either. The successor of AAD pod identity has already been introduced, and that uses Azure Workload Identity, a modern technology where you can impersonate using OpenID Connect. So the OIDC issuer actually stands for OpenID Connect, which is internally based on top of OAuth 2. And using Azure Workload Identity, you can even link Kubernetes clusters that are running outside Azure to your Azure identities, which is quite cool. I was really motivated to show it to you today, but it requires an AKS preview extension that I couldn't get hold of. It's a little bit too new for this tech talk. So all I can promise you is to stay tuned on the link that I've mentioned over here. And I will promise you that I will do the same. If this is all done, then you can achieve the situation in the bottom where you have a default Azure credential, a default connection string that uses integrated authentication, and using the Azure credential token, you'll have impersonated yourself to an Azure identity. Now, the last topic that I want to cover today is around secure containers. We got the secret part and the identity part, but what if the software that's running on your cluster is vulnerable or malware? You don't want that. And if you want to achieve that, there's only one golden rule. You have to know what you deploy. You're probably building your own software, so you're building your own container images. Please base them on well-known official images like Microsoft provides for .NET Core. So if you use a base image like this, then you're probably good to go. Microsoft will make sure that they have done their homework, and you get a pretty okay base container. The container in the left bottom is mentioning Apache's Cassandra. I would trust that as well. It's been marked as an official image on the Docker Hub. It's been downloaded 100 million times, so it's quite used a lot. I would trust that. In contrary to the container that is there in the right bottom. This is actually one of my own. I didn't remember that I had it. It's doing some service discovery for dev work. It's also created 4 years ago. Who knows what's inside it? At least I don't remember it. But still, you can see this container image has been pulled 9 days ago. I wouldn't want to run this container image on my cluster. Who knows what it will do, what it will scan, what it will send, etc. Basically, I trust the left two parts. I don't trust the right part. You have to know what you deploy. If you're still unsure, or if you want to have proof that your image is safe, then there are tools for that. For example, Qualys, but they're actually more third-party tools that you can inject straight in your pipeline. They will scan your image, and if you do it just after building, before pushing, then you're right in time to prevent pushing of malfunctioning container images. So this is about build time, quite okay, but vulnerabilities can be recognized later as well. Suppose I created a container last September, and in last December the log4j vulnerability came out, then still my container is out. It's out in the registries, people can download it, I have probably deployed it. You also need to scan your containers after they are pushed. There are two options for that. In the right, there is the screenshot of the Docker Hub. You see that there is a link here that enables vulnerability scanning. You also have to enable your credit card, but afterwards it works. Microsoft has the same functionality inside Microsoft Azure using their Microsoft Defender for Cloud. And this is actively scanning the images that are present inside Azure Container Registry. As soon as there is a vulnerability found, it will raise an alert and you can hook up your action groups, send an email, or get a push notification, those kind of things. So we've come to the end. Let's go to the slides that I've shown in the start. This was the basic AKS reference architecture. And what did we cover? We shown how our pipelines can work with AKS and how they can do secure Docker pushes, how they can connect to the Kubernetes cluster, how Kubernetes is able to pull images using managed identity. We've protected the API server, and we've protected the API server using Azure role-based access control. And we've also shown how to get your Azure KLYVAULT secrets inside the cluster. At last, we have seen that we can actually pull the external data sources inside our VNET. There are also a few question marks which we didn't cover today. They're all about the Kubernetes internals. Kubernetes has its own security stuff, its roles, its privileges, role bindings, etc. And there are also internal network policies. Like the network security group of the VNet is exposing the outside world or protecting your cluster to the outside world, but Kubernetes has functionality to prevent that front-end pods can directly talk to Elasticsearch, for example. So you can limit the way which namespace can communicate with another namespace. Let's keep that for later. I also didn't talk about the way you're going to expose your front-end application to the outside world. So over there, you have the possibilities for Azure Application Gateway and then the Web Application Firewall, the WAF feature. Let's keep that for later. Last but not least, I want to give you the message that you should not forget all the other security stuff as well. You only need one weakest link and then you're still lost. If you don't do pen testing and people get access inside your container, they will have access to your secrets. If you don't protect your workspace, then people will still have access to your AKS cluster. If you put secrets inside log files, if you don't do the OWASP.10 while developing, etc., you still have to do all the other stuff on top of protecting your AKS infrastructure. Here are a few great articles published by Microsoft on their security baseline and security concepts. Keep an eye on the article about Azure Workload Identity and OpenID Connect. And you can read all about the private DNS endpoints. I guess that was all I had to say to you tonight. So thank you very much for your attention.
Thanks a lot. Really great session. Very interesting. A lot of great security features that you've covered in this. We have some questions for you in the chat. Kaushik was very, very active in the chat. He has 3 questions for you. So let's start with the first one. He asked, is it possible now to manage the API server host certificates and client certificates, such that the on-premise nodes can be integrated with it, more in the direction of Azure Arc, for instance?
Arc enabled AKS. That's quite an interesting question, but I don't have the answer for you. I'm sorry.
Yeah, different product. Yeah. I can imagine that. So yeah, Kaushik, you need to Google that one, I'm afraid. Okay, but he has another one. Let's take the next one. Okay, are there any use cases where there is a need to SSH into the nodes?
Yeah, good question. I think if you're a DevOps agent, and especially while you're troubleshooting or doing when you have complex workloads, then you have also different node groups, and then you have also different network challenges. So in that case, you basically want to go into the nodes and get access to see what you can do if you're running inside a node. I wasn't doing that. I was running in a container inside the cluster, which is slightly different. It gives you the same approach inside the same network. So SSH into the node is like only in case of real troubleshooting, I guess. I wouldn't do this on a daily basis, to be honest.
No. I think I agree on that. I think I read somewhere that this is not a best practice on your production environment. No. So yeah,
The nodes are probably untouched. Like they're managed by AKS as well. So like the security updates on the VMSS, they are all automatically updated. And if you want to update your Kubernetes nodes as well, that also goes through Azure. So if you increase Kubernetes by version, so you go from 123 to 124, then that's a managed command by AKS. The whole idea of having AKS is that you don't need to manage Kubernetes itself. Azure will do that for you.
Yeah, agree. Yeah. Okay, one last one. He agrees that the CSI driver is helpful, but if you use this, are the environment variables still valid on the pod? And does the application needs a sidecar to read secrets from the volume mount?
Yeah, and the latter. I guess you need to inject that as like a separate configuration add-on if you're doing .NET Core development. There's no such thing as that you would have with environment variables. If you're doing a .NET Core development, .NET Core configuration, then you can inject all your environment variables straight into your application settings. There's, well, I guess not natively, there's not an add-on that does the same. So you still need to do something for that, or get a NuGet package that does the same.
Okay. Thanks. And thanks, Kaushik, for your interesting questions. Yeah. Thanks a lot. Yeah. So then we're now at the end of it.
Thank you very much.
You.
I hope it inspired you a bit.
Yeah, it really did. I made some notes, and I'm going to look into a couple of topics that you've covered later on. Yes. Okay. Really interesting. Right. Learned a lot from you. Thanks a lot.
Thank you. Have a nice evening.